Hi everybody, so welcome to the lecture number 2, and today we're going to talk about numbers in Rust, and specifically we're going to talk about signed and unsigned. Okay, look at these code again. Based on the previous lecture, look at this U32 type declaration. We know that we are borrowing 32 bits of storage to store our value of our variable. However, we don't know what signed and unsigned are, so let's move to the definition. So signed and unsigned refer to whether it's possible for a number to be negative. So in other words, whether the number needs to have a sign with it, or whether it will only be ever positive and therefore be represented without a sign. So that's the definition, and it's raised the questions that why do we even need to declare signed and unsigned? If you just use I8 or I32, which is signed, right? It can have both positive and negative and zero values. So you don't have to worry whether the number will be negative or positive. But hey, think again. Sometimes you clearly know that a particular variable can be bigger than 0, right? So thinking of a string length, an index in an array, a file size, an amount of money, and etc. So you may want to use an unsigned type for that variable. So there are several reasons to choose an unsigned type. First of all, is to hint to yourself. So if you use a variable of unsigned type, it clearly reminds you or whoever is reading the code that this value cannot be negative. But sometimes it's just a nice hint, right? Clearly stating this number is natural, or this number is a whole number, or this number is a float number. So it just gives more structure to the code. Second, it hints to the compiler. So if the compiler knows that this variable is never be negative, sometimes it can generate more optimized code. The last one, so you can use more values. Since integers are stored in memory using a finite number of bits, for example, you're using U32, right? So it's 32 bits. So the set of values are possible to represent is limited, right? Limited in those 32 bits. So if you use a signed variable, half of the possible values will be negative, right? Just think about that. On the other hand, if you use an unsigned variable, those values can be used to signify even larger positive value. For example, a 32-bit integer lets you represent value from number 2 to the 31 power to the number 2 to the 31 power minus 1 if you use signed, right? While an unsigned integer gives you a range from 0 to number 2 to the 32 power minus 1. So it is the same number of values, but the values themselves can be larger if you use unsigned integer. That's the big three reasons why you need to state or declare signed and unsigned integer. Okay, let's get back to our table again. Now you can understand all of these type declarations, but how about these two? Right? I size and U size. I size and U size types depend on the architecture of the computer your program is running on. In another word, a 32-bit system, the I size is the same as I32 and the U size is the same as U32. is the same to 64-bit system. The I size is the same as I64, and the U size is the same as U64. And the last one, Rust also has two primitive types for floating point numbers, which are numbers with decimal points. Rust floating point types are F32 and F64, which are respectively 32 bits and 64 bits in size. And last but not least, all floating point types are signed, meaning that they can be either positive or negative. That's the end of this lecture, and coming up next we will talk about some other primitive types like Boolean type or character type. Goodbye.